Hello, everyone. I would like to go through another problem from your textbook on page 366, problem 10.24. In order to do any of these problems, I have to read the problem very, very carefully and see if I could figure out what I need to do. These type of problem deals with test of hypothesis. So in order to do test of hypothesis, the very first thing I need to do is try to determine if dealing with the mean of a population or dealing with the proportion of a population or dealing with the other. So when I read this problem, I look for the what they're looking for. Clearly, that particular problem is looking for the mean. Now, the second thing is, let me go back to the problem and see what else I could get from this. So, this problem is on page 366 and 367. So, let me go to 367 and see that what they are looking for. Obviously, this problem, when I look at that, it's dealing with the two populations. It says before and after, so clearly this is the two populations. And the next thing I need to do, I could go ahead and see if it's independent or unrelated case or dependent or related case. So again, when I read the problem, it says dealing with the patient before and after. So it's the same patient. Therefore, we call this related case, dependent case, or sometimes you may call it paired observation. And last thing I need to do is to determine if it's dealing with one-tail test or two-tail test. Again, this part could be a confusing one, and there is no other way to tell you except to read the problem very carefully and see what the problem is asking. So I'm going to go back to the problem and see if I can determine if it's a one-tail or two-tail test. Uh, Now, when I go back to the problem, I think the very first thing here on the part A, I read it carefully. It says at the zero point zero 0.05 level of significance, is there evidence that the mean bone marrow uh, density is higher before the stem cell transplant than after? So we are trying to determine if the mean before is greater than mean after. So as long as that's the case, this is a one-tail test because something is more than the other. Uh, if you would have said the mean before is different than the mean after, then that would have been a two-tail test. But right now, this is a one-tail test. So let me go back to PowerPoint and see what I need to do. So the very first thing that I do, I say always under HO, the mean of the first group is the same as mean of the second group. It's a little deviation from your book, but I always like to under HO have this way. Mean of the first one is the same as mean of the second one. Under alternative, I have mean of first group is more than the mean of the second group, and that's obviously a one-tail test. And then in part step three, I make sure I know sample size for each. Each of them is 7. But remember, this is a paired observation, so I should know about degrees of freedom here. It's 7 minus 1, which is 6. And also I know about level of significance by reading the problem. And now I got to go to different software and try to solve the problem because I don't want to do it manually. So let me go to StatCrunch. And again, I'm going back to Pearson side now. And I'm trying to activate StatCrunch. And now when I go to StatCrunch, it gives me two options. One, I can read the data set from the textbook right away, or I could store the data somewhere else and then try to retrieve the data that way. Since I already stored the data, I'm going to the second option, although I think for you guys, this must be easier option, usually. So I'm going to this one. And now here I want to retrieve my data while I already stored it on my computer. So I go there and I need to find where my data is. Eventually I can see my data and right here this is my data and I can open it up. So the data right now is on the website, but I could pull it up and load it, and it's going to go to StatCrunch. So the data is right now in a StatCrunch. Remember, I had seven patients, and I have a before and after. And all I have to do now run the statistical test. So it makes sense to go to Stat. And now I know I have to use a t-test for paired observation right away here. And remember, this was a dependent case. That's why I go to the paired case. Now it's telling me about the first one, first group. Actually, it's before. The second group is after. And I can save the differences. I need to say under HO, the mean difference is equal to 0. Under alternative, mean difference is more than 0. And my alpha, I could always uh, go back and see what it is. And output stored in the data table, I could ask for that. Now I'm going to compute this. Gonna, oh gosh, didn't like one of the thing I didn't do. So let me uh, forget about that one. Okay, let me forget about that one. I put this information here. So here it says the degrees of freedom is 6, and the statistical test is basically 1.84, and p-value is 0.057. 0.057. So if I go back to the problem and just look at the alpha level was 0.05. So that's my p-value. Uh, Sorry, this my p-value is 0.0574, and my level of significant alpha is 0.05, and therefore, basically, my p-value is more than 0.05, and therefore, I do not reject HO. So let me go back to PowerPoint and complete the problem. And so far, I had this much. And now, based on my statistical test and my alpha and my p-value, I could make a decision. Remember, my p-value was slightly more than 0.05. It was 0.057, and my level of significance or alpha is 0.05. Therefore, I can say since my p-value is more than alpha, I do not reject HO. So I could say decision, do not reject HO. And the reason was my p-value was more than my alpha. And I can conclude that based on this information, I have a reason to believe that mean of the first group, statistically speaking, is uh, so close to the mean of the second group that they can be called equal, statistically speaking. Um, and these conclude the problem. And if you have any question, you can email me. I appreciate your comment. Thank you.